Single-acting pump. When a piston of a pump takes a single suction and discharge stroke in one cycle, it is called a single-acting pump. When the piston moves up and down in a cylinder, the liquid creates pressure pulsations in the discharge pipe as seen in the animation. As the piston moves from A to C, it reaches maximum speed at B before slowing down to a stop at C. The piston stops and reverses its direction from C to A. Hence, the pressure is highest at B and lowest at A and C. The cycle is then repeated. Double-acting pump. When a piston takes 2 suction strokes and 2 discharge strokes in one cycle, it is called a double-acting pump. When the piston moves to the right, the suction valve on the lower left opens due to low pressure to allow liquid to fill the cylinder. The fluid on the right side of the piston builds up sufficient pressure to open the discharge valve above. The reverse happens when the piston returns to the left. Unlike single-acting pumps, where there are no discharges during one stroke of the piston, in double-acting pumps the pulsations are still there. However, the gaps have now become closer because there are 2 discharge strokes per cycle. There are discharges during the upstroke and downstroke. The fluid pressure builds up and then comes to zero when the piston comes to a stop. Accumulators. Pressure pulsations cause the pipes to vibrate severely, producing stress that shortens the lifespan of the materials. To reduce this effect, accumulators are employed. Accumulators store some pressure energy during the high-pressure stroke and release this energy to the system during the low-pressure stroke. Accumulator is a container that is filled with air, airbags or spring-loaded devices. As the piston moves to B in its upward stroke, some energy is used to compress the spring. Therefore, the spring has stored energy. At point C, this energy is released when the fluid pressure drops below the compressed spring pressure. The spring now acts like a tiny pump that exerts small additional pressure on the fluid. A sharp drop of pressure is avoided. The pressure pulsations are now reduced greatly and tend towards a straight line. Vibrations in the pipes are minimized.